Welcome to another awesome edition of Comet Algebra. This video is for Algebra 1, Chapter 11, Section 1, Expressing Roots. Now we learned about square roots in pre-algebra, but we're going to learn about them a little more and deepen our understanding of them and hopefully learn where we're going to use them. So first, let's go over the definition of what is a square root. The textbook definition, it's one of two equal factors. Another way we could say that is a number, or it could be a variable also, so this isn't a perfect definition. So it's a number times itself is the root. So when we're asked here to find the square root of 16, we're asked to find what number times itself equals 16. And in this case, it's 4 times 4 is 16. When there's a negative sign sitting out in front of the radical, it means that we're going to have to multiply our answer times this negative 1. I kind of picture that as a negative 1 sitting there. So the square root of 25 is 5, but we want negative 1 times that, so it's negative 5. Now here, we kind of have a problem. Is there a number that if you multiply it times itself, you get a negative 25? Well, if you thought the answer was negative 5 and you try it and you multiply it by itself, you do not get a negative 25. You get a positive. So for right now, we're going to just call this, there is no real solution here. There is a solution, and it lies in the land of imaginary numbers. It lives there with unicorns and glitter, and we will talk about imaginary numbers when you reach Algebra 2. But for right now, we're just going to say the square root of a negative number has no real answer. Now you're going to recognize many of the perfect squares because if you know your times tables, they're not too bad. But we are going to have a quiz in class where you write in the perfect squares, like 1 times 1 is 1, 3 times 3 is 9, 7 times 7 is 49, all the way up to 15 times 15 is 225. So you're going to get pretty good at recognizing square roots. Cube roots, on the other hand, are not so easily recognized. They're just not as commonly worked with. But a cube root is a number that you multiply itself 3 times. So the cube root of 8, again, we don't recognize this, but it really is 2, because 2 times 2 times 2 is 8. Now we're looking at this cube root of a negative 8. You may think, oh, it's got to be like this one where there's no real solution. Well, that is not the case. Finding the cube root of a negative number is no problem at all, because if you think about it, negative 2 times itself 3 times. 3 times. That's supposed to be a 2. So let's do this. Negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. So when there's 3 of these negative signs, we do end up with a negative 8. So this is absolutely no problem. The cube root of a negative 8 is negative 2. Sometimes we need to work with larger roots than just a cube root or a square root, so we need to be able to find the nth root key in our calculator. And it just means, if there's an n here, n can be anything. It could be the 4th root, 5th root, 6th root, and so on. So it's handy to find this on our calculator. So if you look under the math menu and scroll down, I think you'll find the square root key, the cube root key, and when you find this and you punch that, you can enter any root there you want. So if you want to find that now and enter in the 4th root of 81, meaning what times itself 4 times is 81, it should give you a 3. And if you enter the 5th root of a negative 32, it should give you a negative 2. Because negative 2 times itself 5 times does indeed give you a negative 32. The next skill we're going to discuss is pretty handy to have, and it's mentally estimating square roots. And this is why I want you to know the perfect squares up to 15 times 15 is 225, because then you can look at numbers and you can sort of figure out which 2 perfect squares they're in between. Now this one's kind of easy, because you know that 2 times 2 is 4, and 3 times 3 is 9, and so this this estimation, this number square root 7, is going to be in between 2 and 3. So they will ask you to estimate it to the nearest integer. And we notice that 7 is a little closer to 9 than it is to 4. So to the nearest integer, you could say 3 here, but we know it's going to be a little smaller than that. And then we can use our calc to find the exact value of the square root of 7. So I guess I really should put approximately equal to there. When I think about it, a more accurate estimate to this square root would be about 2.5. So let's look at the square root of 125. And so we're thinking again to the ones that we know. 10 squared is 100, 11 squared is 121, and 12 squared is 144. And we notice that this 129 is halfway in between here. So a really good estimate of this is, well, it's going to be 11 point something, but it's closer to that 121. So maybe a good guess I might have is 11.3. But again, in your assignment, they do ask you to estimate to the nearest integer. So if you estimated this one at 11, close enough. All right, now let's look at what's called rational exponents. In other words, when you have a fraction up here in the exponent. So first I want you to do something on your calculator. Punch in the square root of 9, and of course we get an answer of 3. Now I want you to enter 9 to the 1/2 power and see what that gives you. And then find the third root of 125, which I think you will find is 5, and then type in 125 to the 1/3 power and see what your calc tells you then. So I hope you're noticing something. I hope you noticed that when you did the square root of 9, you got 3. And when you did 9 to the 1/2 power, you got 3. When you did the cube root of 125, you got 5. 125 to the 1/3 power also gives you 5. So there's a connection here we can make. Now try this one. Try the third root of 5 squared and 5 to the 2/3 power, and see what your calc says then. And I'm betting it's going to give you the same answer. So let's write this. This is what we call converting from radical form to exponential form. And we need to be able to go both ways with this conversion. Okay, you can tell this is very important because of all the stars here. When you have x to the ab in a rational exponent here, this top number, this a, is the exponent on the x, and this bottom number on the fraction becomes the root. And so I just wrote that as x to the exponent over the root when it's in exponential form. So take a minute, write this down, maybe put that in color where you notice that, let's see if I can use this, the red marker here. For the a, the top, the numerator is the exponent, and the denominator is the root. And so use some highlighting or some color and make that really clear in your notes. So let's do a couple examples of each type of conversion. Here we're given in exponential form, and it says convert to radical form. So remember, this denominator is the root. So this is going to be a 4th root of, and then 7 is our number, and this top number is the exponent. So it's the 4th root of 7 cubed. And 7 cubed is 343, so this is the 4th root of 343. Now in this next example, we want to convert this into radical form, except we have a problem. We don't have the same root here with a denominator of 2 and 4 and 8. So we can't even find a common root here until we change these fractions, and they all must have the same denominator. So we need to rewrite this 1/2. 4, 2, and 8 all have a common denominator of 8. So the 1/2, we're going to rewrite that as 4/8. And then the exponent on the x is 1/4. We want to times both of those by 2 and get 2/8. So now that's in eighths. And I do not have to change the exponent on the y because it's already in eighths. So now that these all have the same denominator, I know that we're going to have an eighth root of all the stuff inside here. So what's left here with the 3 has an exponent of 4, the x has an exponent of 2, and the y has an exponent of 3. And we can do this 3 to the 4th power. 3 to the 4th is 81. So this becomes the eighth root of 81x squared y cubed. Now let's do a couple of problems going the other way, where we're given the radical form and they want us to convert to exponential form. Remember, the root is the denominator of our fractional exponent, and this is the numerator. So this becomes x to the 3/5 power. This one is a little more complicated. Each piece has its own exponent. So the 7 is 7 to the 1st power, and the denominator on all of them is this 4. So this becomes 7 to the 1/4 times x to the 3/4 times y to the 2/4. And when you can, you do reduce those fractions like we always have. So we'll leave that one, 7 to the 1/4, x to the 3/4. But this y, we reduce that to a 1/2, and now it is written in radical form. All right, now you have the knowledge you need for 11.1, so have fun with math.